In this video, we'll deal with the fundamentals of the turbomachines. That is, we are going to see the Euler equation. So what are rotating machines? Rotating machines are called as turbomachines. And turbomachines are a sort of device in which the rotating fluid interacts with the rotor, which rotates about an axis, and transfer its energy to the rotor, or the rotor may transfer its energy from itself to the fluid. This may happen in a turbomachine. So when a fluid interacts with the rotor, two things takes place. First one is the energy transfer. That is, the fluid may transfer its energy to the rotor, or the rotor may transfer its energy to the fluid. And second is the energy transformation. That is, energy is transferred from one kind of energy to the another one. In case of energy transfer, the energy transfer takes place in the rotating parts, and it may be transferred to the fluid, to the rotor, or the vice versa. If the energy is transferred from fluid to the rotor, it is called as a turbine, and in case if the energy is transferred from the rotor to the fluid, we call it as a compressor. And to remember you, energy transfer takes place only in the rotating parts. This is what we have seen. And all the thing that we need to know is the compression is a process in which the rotor gives its energy to the fluid and it makes it as a pressurized. Next is the energy transformation. The energy transformation takes place in both the rotating and the stationary parts. What are the stationary parts? The stationary part may be the inlet, exit, or all the called as stationary parts. And energy transformation means the change of kinetic energy to the pressurized in case of a compressor. What a compressor does, it imparts all the energy to the fluid and converts its kinetic energy of the fluid into a pressurized. This is what happens in the compressor. This is the energy transformation that happens. So on what basis are all these developed? The basis of the turbomachines is the Newton's second law, or sometimes it may be a combination of Newton's second and the Newton's third law. What is Newton's second law? It states that the rate of change of momentum is directly proportional to the force applied. So what is the force here? That is, when a rotor rotates about an axis, there comes an angular momentum. So if an angular momentum takes place for a second, there develops a torque. So in case of turbomachines, the rate of change of angular momentum is directly proportional to the torque applied. This is the basic funda of the turbomachines. On this basic, we derive all other equations for the turbomachines. And again I repeat, we have seen what is a turbomachine and what are the two main things that happen in the turbomachines. One is the energy transfer and second is the energy transformation. Consider a mass of fluid M with a tangential velocity c1 is hitting the rotor at a distance r1 from the axis of rotation, and it leaves the rotor at a distance r2 with a tangential velocity c2 and with the same mass m. The rotor rotates about an axis AA with an angular momentum omega radians per second. If this is the case, we'll derive what happens actually and what is the energy transfer that takes place here. So I told you earlier that energy transfer takes place only in the rotating components. So what is the energy transfer that happens? How it is being calculated and what is the efficient way of calculation? That is what the Euler's equation gives us. So we'll derive the equation now. The angular momentum at the inlet is now what? What is angular momentum? Angular momentum is mvr. M is mass of the fluid, V is velocity, and R is the radial distance. The angular momentum at the exit will be M into C2 into R2. Now we'll apply the Newton's second law. So what is Newton's second law? Newton's second law is it states that the rate of change of angular momentum is directly proportional to the applied torque. So the rate of change of momentum is what? mc2r2 minus mc1r1. So now this is the application of Newton's second law. And the next one, the energy transfer. Energy is what? E is equal to torque into angular momentum. Torque is what? mc2r2 minus mc1r1 into omega. Now taking the m common, the remaining things will be c2r2 minus c1r1 into omega. Multiply the omega, m into c2r2 omega minus c1r1 omega. Now E is equal to, we know that the velocity u is equal to r omega. This velocity is what? Tangential velocity. So velocity is equal to r omega. Now we'll substitute it here. R omega, instead of r omega 2, omega r2, we'll substitute u2. This u2 is called as, see, the u2 is the tangential velocity of the rotor. And C2 is the tangential velocity of the fluid. And finally, if the mass is equal to 1, that is a unit mass is appearing, then the final equation will be E is equal to C2U2 minus C1U1. From this, we'll find one thing. If C2U2 is greater than C1U1, the energy transfer is positive and we call it as a turbine. And in case if C2U2 is less than C1U1, the energy transfer is negative and we call it as a compressor. Finally, the energy transfer equation for a turbine is C2U2 minus C1U1, and the energy transfer for a compressor is C1U1 minus C2U2. This is the Euler's equation. In case of this Euler's equation, this is a basic fundamental equation that can be applied to any of the turbo machines. That is a compressor or a turbine or anything, we can apply it.